Hello everyone. Today let's work on leetcode 1606. Find servers that handle most number of requests. So let's first see what this question is about. So we're given k servers. So these k servers are numbered from 0 to k minus 1. And we will receive a list of requests, and the requests are assigned to those servers to process, and it is guaranteed that the request arrival time are strictly increasing. And we assign those requests to servers based on the following three conditions. So the first one is the ith request arrives, then we we got the request. Then if all the servers are busy, then this request is just ignored, dropped. And then we will assign it to some server if at least one of the server is free. So we prioritize the I modular by case server. So for example, we have three servers and I is the third one. So then 3 modular 3 is 0. So we prefer to assign it at the 0th server. However, if this server is not available, we will try to increase the server number by 1. So we will try to see if the first server is the one server is available. If that's available, we assign it to index 1 server. Otherwise, we check the index 2 server, etc. So we are required to return a vector. This vector includes all the servers which has the maximum number of requests processed. We are returning a list because there could be multiple servers have processed equal number of requests. Okay, let's look at this example first. So here we have k equals 3, which means we have 3 servers. This is the arrival, and each one means the arrival time. Then we have the load. So this load means for the corresponding arrival request, how long should we take to process it? So this question is actually a simulation problem. Okay, let's use this example. For example, we go through it. So every time we receive a request, then we will check about for the server we will insert it to. So for example, this one we will first check server 0, and we found server 0 is empty, is available, so we put it into server 0. And this length is 5 because it takes 5 timestamps to process it. Then here we arrived the second request, and this request need 2 time period to finish. And this is index 1, so we check server 1 first, and we found it's available because currently we are at timestamp 2, right? So it's available. Then we put it for server 1. Then we have this request. The same process, then we decide to put it at server 2. Then we found this request. This request arrived at time 4, so it's this time. At this time, all the servers, the server 0 and server 2 are still running other requests. However, server 1 it just finished, so we can assign it to this server, right? We can assign it to this server. Then we came to this one. This one is R4. The index is 4. So for this one, it's at time 5. So it's time 5. However, at this time, we can see that all the 3 servers are busy, so that we just throw this away, ignore it. Okay, so in the end, server 1 process 2 requests, and all the other server just process 1 request. So we return server 1. This output is just one item in the vector. Okay, this is actually a simulation problem. So in order to simulate this process very efficiently, we need to choose some data structures to help us to simulate. Let's see, the k is on the order of 10 to the 5th, right? So we have 10 to the 5th servers, and the arrival and load are also on the order of 10 to the 5th. So which means the process that we determine which server we need to process some certain arrival request must be done in either constant time or log time. Okay, so we can simulate the process, right? However, we need to process each request. Okay, so this is on the order of n requests. Okay, then for each request, need to determine which server to process it. Okay, this need to be done in const or log time. Okay, so how to do this? A natural thinking is that we can put all the requests, all the available servers into a set. Okay, if we put all the available servers in a set and maintain it for each iteration. Okay, in order to maintain it for each iteration, we need to dynamically throw away all the servers that are busy, right? And then we also need to for each new timestamp, we need to add back all the server which has already processed some requests. So then we have a min heap to store the end time of a request and also the server ID index. Okay, so we use a min heap to store this. Then if we have a new timestamp, we just pop the elements from this min heap until that this reaches the current time. Okay, so that is the basic idea, and let's see how the code will be written. So we have a min heap, so we use a priority queue, and we actually define this PII, pair int. This will save a lot of writing. PII vector PII, then std greater PII. Okay, this is our min heap. So we use priority queue, but we use some std greater because the default way is max heap. We're actually using a min heap here. Then we need a set of int to record all the servers. Then we initialize the server. Servers insert I. Okay, then for each one, okay, for each one, we will first check if we can pop anything from this priority queue. Okay, so queue size and queue top. The time is first, right? If it's less or equal to current arrival time, then we can pop it. Okay, but before we pop it, remember to add it, because if it is popped, then it means it's an available server. Then we can add it back to this server list, a server set. Okay, second is a server. Okay, and for now we have already processed the server. So the server is the actual available server for this cycle. So if the server is empty, it means we can just continue, ignore the current one. Then we find the element in this server, which is the first element greater than I modular by k. Okay, so if we don't have anything, it's end, then it is just the begin of this server set. Then we can use the hash function to remember which one has how many requests has been processed by each server. Okay, so this is we can actually define it by a vector. This may be quicker. Then it is k element initialized to 0. Then we will push it back into this queue, because it will process a new request. And what is the end time of this new request? So it is beginning at arrival I, and we'll need load I to finish, right? Then server indexes the star IT. Then we need to remove it from the servers. And I think that is for the for loop part. And then we will just output the result. We initialize these two, and for I equals 0, I less the hash size plus I. If hash I greater than count, then res is equal to I alone. Okay, otherwise if I equal to count, then res push back I. Okay, what we need to do, so for here we need to update count as well, right? Hash I. Then we just return res. Okay, it seems it's working. Let's see if it can pass all the tests. Yeah, I think it works. This is not a very hard question, but you need to think about which kind of data structure to store those values, because this is just a simulation problem. However, for each step, you need to process to find out the server very efficiently. So our idea is to use a set so that we can use a lower bound to find the server in log time. Then when we update, it's also a log time. And because for this step, it's actually a little bit tricky to analyze the time complexity. However, if you remember that, so for every item arrives, okay, so what's inside this server? What's inside this priority queue? So it means some task, right, with its end time and which server to process. So for each task, it just add into this queue once and be popped up once. So the total time is linear. So this seems like a double for loop. However, the total time complexity for this is still linear. Okay. So let's, I think we can stop here for this problem, and that's all for today. Thank you for watching, and see you next time.